folks. This is Chris Breedlove here with Duncan-Parnell. Thanks so much again for joining us this morning. I know some other folks will be trickling in the next minute or two. We're going to go ahead and get started with the program. Let me go ahead and get myself situated here, and we will kick off. So as I'm getting the slide deck pulled up, folks, obviously this is an intro to mobile mapping discussion. That's the whole purpose for this session here today. And what we really want to try to do with that is just highlight Trimble's mobile mapping portfolio. Some of you, I think, based off the registrations I saw, may have little to no prior experience with that. Others may have many years of experience, even with Trimble gear or other mobile mapping systems. So we definitely want to highlight those products, those three main products in our product line, kind of introduce Duncan-Parnell's rental program of that gear, the MX7 and MX9. And then Skyler has joined us from Trimble to kind of go into a deeper dive comparing MX50 and MX9 data sets. And at the tail end of that, he'll go into at least one Trimble Business Center mobile mapping workflow. So based off you all's feedback. So with that, let me actually launch a couple quick poll questions, and we might miss a few of the stragglers, but that's perfectly fine. So if you will, as this poll question comes up, go ahead and just respond. We'll take just a minute or two, probably just a minute to do that. So that poll should be coming up any time now on the screen. Again, please just go ahead and pick whatever best applies to you. And as y'all are doing that, I will say this. Yeah, again, this is really designed to be just an introduction. Some of the folks on this call we've been in conversations with for a while. You have very particular needs. You do a lot of terrestrial scanning. Others might be coming more from a GIS perspective. That's certainly my background as well before I joined Duncan-Parnell for this role. So we're going to try to hit just the absolute foundational highlights of that, just for those who might be new to this whole arena. But like I said, we'll kind of move towards the latter half of this into kind of a deeper dive. So trying to kind of hit all sides of the spectrum, wherever folks may be coming from. And then a couple quick housekeeping items as folks wrap up their votes here on this poll question number one. Everybody is muted by default as you join the session. Feel free to go off mute if you really need to. We'll try to save all the questions towards the end if you would. And of course, as in many webinars, just drop them in the chat as well if you'd like as we go. But we'll have hopefully 10 to 15 minutes at the tail end of this session for Q&A. So great to see a couple more votes trickling through. It's about what I kind of expected. We'll go ahead and let a couple more votes get through there. Excellent, good. And I'll throw one more question up for you all, and this one will be all about which Trimble Business Center workflow you might like to see. And if TBC is utterly foreign to you, just which of these might be most relevant to your practice area, or at least what you anticipate. So I should see that poll question number two right now. We'll give just a minute again to vote there. Awesome, and this is choose your own adventure, so get your votes in, and we'll. Skyler may have time to go into more than one of these, but we'll let the poll decide that. Give y'all just another few seconds. All right, it's a tug of war. Let's see. Let's give it one more vote. Or Skyler will do double duty. All right. Yeah, thanks y'all for doing that. So we got as-built asset management. There we go. All right, let's get back into it, guys. So again, that's our agenda for today. Thanks so much for participating in the poll. Again, glad to see kind of a broad representation of folks with different levels of experience with terrestrial scanning or mobile LiDAR and imagery as well. And now we'll kind of get into it. So first things first, when we say mobile mapping, obviously that could be anything. It could include UAVs, airborne, could include walking, handheld backpack mounted systems, all the above. We're really today laser focused on vehicular mounted systems. So, car, truck, ATV, could put it on a train, could put these systems on a boat even. So that's really kind of the arena we're drilling down on with these products today, the MX7, the MX50, and the MX9. Now, regardless of which solution you use, Trimble or otherwise, those three best practices there really will help ensure the maximum success, at least of your field data capture. So for that number one, on-site base station. Now, of course, if you're just doing some GIS, asset extraction, sub-meter, several feet is sufficient. You may be fine without a base station, but if you're doing the higher end engineering survey level accuracy projects, That really is critical. And those latter two are all about just best practices in the field as far as how your operator is driving their system. So dynamic meaning to say you don't just pull out of the parking lot and start capturing. You'll do some figure eights, some starts and stops, get up to speed if you can, 55 and up on a highway. And that'll just help your initialization of the system, your positioning system, drive your heading values down and just ensure just a better ultimate trajectory. We'll talk about that in a moment as well. And then static session, meaning to say you've parked under open skies, right? Just to help capture as many satellites as possible to further refine your positioning solution. So again, that's just great advice, regardless of which mobile mapping, Trimble or otherwise system you may use. And then quick terms to know, again, for anybody who's not as familiar with any kind of, again, drone-based or mobile mapping, if you're more of a GIS person like myself, as I've come from. Trajectory, I think most of us are familiar with. That's the path that the system is actually taking. It's pretty self-explanatory. But to refine that ultimate trajectory in your post-processing steps, there are several pieces of equipment that help with that. So first and foremost, the IMU, right? So each of these three products, the MX7, MX50, and MX9, they all have different attributes and specs, but the IMU really does escalate tremendously amongst those three. And we'll talk about that more, but that's the inertial measurement unit. It defines and captures the sensor's orientation in space. And so again, when choosing a mobile mapping solution that best fits your project needs, knowing the grade of the IMU and your final project accuracy requirements is very critical. And those other two, DMI is the distance measuring instrument. You actually see that in this photo here on the wheel hub. And that basically records the wheel revolutions, which can be very helpful during GNSS outage situations, or if you're stopped, right? So if the IMU is going to start drifting while you're stuck at the 90-second red light, that DMI can help control for that in post-processing. And that last one, GAMS, is really a secondary GNSS antenna that again can help just improve during GNSS outages, shorten your initialization times, and those sorts of things. And so again, just throwing out a couple of those terms to define as we go through the product portfolio for folks who may be less familiar. And again, this is all just a foundational introduction. A lot more could be said about all of these things. We unfortunately don't have time for that today. So we'll keep running. And again, use cases here, right? If you're doing image only capture, which is the MX7, whether you're doing kind of mid-tier scanning with MX50, focusing on road surfaces and that sort of thing, or kind of doing it all and adding into the mix high-resolution planar cameras, maybe to read asset tags on utility poles. You know, everything you see here and more is all possible with this data, right? Like anything else, you know, data you get out what you put into it, right? Good data, good field practices is a great foundation, but understanding where your project requirements are, your end customer, their client requirements, if it's a DOT situation, on and on and on. So lots of ways to leverage this technology and more that I'm sure folks haven't even contemplated yet. So here's that portfolio. I keep kind of mentioning the MX7, MX50, and MX9. Many similarities amongst all three. We'll talk about that more as well. But this kind of gives you in one shot, in one slide, the breakdown of the capabilities. So for panoramic imagery, that spherical camera, which is a Ladybug 5 Plus, that really is the MX7. The 50 and 9 have the exact same camera. So you kind of add to each system adds more elements to it, right? So the MX50 adds into Trimble laser profilers. They're actually basically X7s. And then the MX9 is actually Regal laser heads. It also adds in 12 megapixel planar cameras. So you can imagine, again, and this slide breaks it down for you, depending on project needs, what type of information you need, higher resolution imagery requirements, so on and so forth. You pick your own adventure. And I'll also point out over there on the software side, the software workflow, I won't say it's identical just because the MX7 being imagery only just doesn't need a lot of the Trimble Business Center modules that the LiDAR processing does require, but you use the same core workflow. We'll talk about that a little bit more as well. The last thing to kind of say at this point is, again, back to the IMU conversation. You'll see there in the elevator pitch column, the 50 actually has two options. So if you're really more looking for capturing a point cloud, maybe relying upon automated feature extraction or semi-automated feature extraction in something like TBC or other softwares, that AP20 IMU may be a great option for you. You're not worried about getting down to 5 millimeter or a centimeter to engineering accuracy. That's great, and that comes with the cost savings. But if you really do need that ultimate engineering level accuracy with the positioning, you can still get the highest end IMU, that AP60, which is what the only option on the 9, but it is a more expensive option on the 50. So just know that as well. Not a lot of other options with the main systems themselves. Some of the accessories we've talked about already and other third-party add-ons are certainly possible. So it really can be, for you, the end user, pick the kit, assemble the kit that really makes the most sense for your needs. And to kind of reiterate that exact same slide here, again, you build on it. So you got panoramic imagery with all of them. You add in LiDAR with some different specifications for the 50 and 9, and then only the 9 actually has built-in oblique or planar cameras. And I already kind of alluded to this, but there are a lot of shared traits amongst all three of these products. So first and foremost, the field capture interface called TMI, which is just a web-based application. So you bring your own device. Each of the systems provide their own local network, their own Wi-Fi. You just connect to that with your phone, tablet, or laptop, and off you go. You update your capture settings per that particular mission, and there you go. So really nice for folks who might get started doing imagery only capture with the MX7 and might graduate to a different system later. You will need some other bits. The roof racks are not the same, for example, from the 7 to the 50 and 9, but that operator experience in the field is the same, using the same tool. In addition to that, the back office software tools start off the same. Use a Planex's POSPAC MMS for trajectory processing. Use Trimble Business Center in the case of the MX7 to stitch the imagery together. And in the case of the 50 and 9, do that plus process your point cloud. So again, very similar workflows regardless which piece of hardware you actually use. As already mentioned, the camera is the same. The games accessory, that secondary GNSS antenna, is exactly the same across all three. And again, the 50 and 9, their setup, everything about them except for the sensor head itself is exactly the same. Which again is just a nice kind of modular aspect. So if somebody, for example, were to purchase an MX50 because that meets their project needs 90% of the time, but you find yourself needing that greater range or other attributes of the MX9, you could rent that for the life of that project. You literally just plug it in, throw it on your roof rack with your vehicle already set up with everything else that you already own, and off you go. And again, just another way to kind of look at each of these three pieces of hardware. Again, MX7 is great for GIS applications, whether folks just want to have kind of time-stamped georeferenced street view type imagery on their own intervals that they control, and then do lots of feature extraction from that. A lot of the telecom and fiber network planning folks really like that workflow. And crack detection is one we've seen a lot more. Of course, you can do grades of that with point clouds and higher res imagery, but even the panoramic Ladybug 5 Plus can be fed into a lot of third-party tools for that as well. And then kind of moving over to the MX50 again, it is kind of the mid-tier system, especially with that lesser IMU, but it does have that highest end IMU option. And you're really basically comparing, do you need planar cameras or not between the 50 and 9, and then the range that you need. You can see that they're up to 80 meters for the 50, getting 150 meters and up with the 9. So for a lot of folks, if the road surface itself is king, if that's really the main focus of your projects, the MX50 is an outstanding option, and you can save some money in doing so. But if you need to ultimately see all, do all, just have maximum options and not worry about maybe driving every single lane on an interstate if you're not otherwise required to by the DOT in which the state you're working in, the 9 really is the ultimate Cadillac, the highest end system. So to get into the software workflow again, just very, very briefly, like I said, all systems start off with TMI. You then will process your raw trajectory in POSPAC, and then kick that into Trimble Business Center for the MX7 to generate those panoramic images. Now after that, this slide shows TMX, and there's multiple packages within that: Asset Modeler, Publisher, Content Manager, etc. Those are all really orbit-based products, kind of brought into the Trimble world, Trimble ecosystem. That's just one option. So some folks could take all this imagery out of TBC, go straight into Mapillary, consume through the plugin there at ArcGIS Pro. That's a great workflow. Or you can extract a lot of assets directly in TBC, and on and on. So I just want to make the point clear here and on the next slide with the 50 and 9, you're not really wedded to any kind of finishing workflow. We like to say that Trimble does have a field to finish workflow, and we do. We do offer that. Some folks make all their hay in TBC, but if folks have a preferred other tool for managing point clouds or doing feature extraction, you have compatibility there as well to export out to whatever formats those other systems might need. And then to that point with the 50 and 9, obviously some different processing that goes on to deal with the point clouds. But once you've generated scans, registered them to control and to each other, you could actually right from there kick it out into a topo dive, for example, which is what a lot of folks doing DOT work really kind of live and breathe on. But many of the same tools are available in TBC. So again, it comes down to personal preference. If you're a microstation shop already, maybe topo dive is a better fit. If you're not, you have some choices there. And again, more than I'm even showing on the screen here. So the point is there is some flexibility built in. But regardless, across all three of these platforms, you'll use TMI, again, web-based in the field, Planix POSPAC for trajectory processing, and TBC, at least for your initial kind of raw data, getting it to a point, and then from there, you go on. And I should also point out as well that for the mobile mapping module that is required to process both the MX50 and 9's data sets, you can actually operate your trajectory processing, the POSPAC functionality, direct in TBC. Still have to have the license, but you can actually avoid opening up an additional software. And again, just to kind of dig in just momentarily, and this is where we're funneling to for when Skyler takes over here in a moment to really kind of do a deeper dive on the 50 versus the 9. Why the MX50? Why is it a great choice? And I kind of mentioned this a little bit earlier, but if you're in a state where the DOT requirements require you to drive every lane anyway, that slightly reduced range might not matter as much in that context. Conversely, if you're in a situation where you can drive maybe inside lane, outside lane only, maybe that greater range will allow you to get the necessary point density. So just something to think about there. The probably the main highlight on this slide is just to say that the scanners, really the X7s, the Trimble lasers on the 50, offer the cleanest point clouds on the market. So that 2 millimeter, 2.5 millimeter. So it's just slightly above the Regal laser heads that actually are in the MX9. And you see some other comparisons there as well. And all of that, the so what is that we can actually offer the MX50 at a decent price rate relative to the MX9, among some of the other features, just because those lasers are manufactured by Trimble. And then for the 9, these 4 bullet points are really comparing it to the other kind of Cadillac, just top of the line systems out in the marketplace. You could say the same things about the MX50. It's just not maybe going quite as toe to toe with some of those systems. And then not to get into the specs too much, I've already mentioned it's Regal laser heads on the 9, those 12 megapixel planar cameras. You can kind of see one of the forward looking ones there on the graphic. The highest end IMU that's out there, pretty quick and easy. You do need a partner or buddy to lift that thing up there. It's about just under 80 pounds, so relatively lightweight again compared to its peers, but this is not a solo lift to get the system mounted on your roof rack. And then just to kind of button this up before we jump over into the rental program momentarily and then kick it to Skyler, again, kind of the takeaways between the 50 and the 9, what are your ultimate requirements? So single return, cleanest road cross sections you can imagine, 50 is awesome for that. If you're trying to operate more like in a mining situation or off-road, there's going to be a lot of dust kicked up, or you're in a rainier environment, not going to operate in a hurricane, but you can't operate in a mist and so forth, 50 will struggle because it is a single return system versus the MX9, which is multi-return. And again, the point density, you can see the difference there as well. So again, they are remarkably similar systems. There is that cross compatibility or ability to switch out one or the other once you've had all the other accessories and the roof rack and so forth. But when it comes time to decide what best fits your most common projects, those are kind of the high level considerations to think about. So with that, just real briefly here, so what is Duncan-Parnell's rental program? We just came out with this in the last, a month or two. So really 2 pathways here. First, you can purchase a starter kit, lock yourself in as a preferred customer, and that means when it comes time to rent, you will just receive the sensor head itself. You've got all the cables, the tools, the roof rack, everything else that you need, and off you go. The other option would be to do our so-called graduated hardware rental program. And that means we're sending you all of the hardware you need. So of course, there's a difference in price. I'll show that here in a second. But a key point I do want to make here for everybody, you must have the processing software. So at least at this time, and I don't see this changing anytime soon, we're not going to rent you a POSPAC license or a TBC license. So there's different tiers and subscriptions, all that good stuff. But yet, on some level, you must either own that software or have a partnership with somebody who does to get that raw data off the systems and make it usable. So we will do that for you, and we'll talk about this in a second during a pilot day program. But after that, of course, we are a distributor at the end of the day. We are not a service provider. So you do need to acquire that software somehow or another. We do also have some third-party processing partners who are well-versed in taking the raw data off any of these systems and either processing the imagery or the point clouds and doing more beyond that. So that's another option as well for folks who want to get into this, maybe aren't quite yet ready to make that commitment on the software. And again, here's the breakdown. You can kind of see the difference there. You make that starter kit investment, get to table 1 rates on the left. If you don't, table 2 on the right. And I should point out for that table 2, day 3 is a lifetime. So it's not, you start off, for example, with MX9 for $7,500 a day, rent it for 2 to 4 days, and then you come back 6 months later, you start over again. No, it's going to be that 15.5 perpetually until you either buy a starter kit or maybe purchase a whole system. Just be aware of that. And as well, I should point out, if someone starts a rental either way, within the month you choose to purchase the whole system, we will certainly credit that 30 days of rental towards the purchase. So if you rent it for 6 months in a row, probably not going to do the whole 6 months, but we can do at least the most recent 30 days prior to purchase. So just be aware of that. And then last, I kind of alluded to this as well, but the paid pilot days, this is really designed as the very first step for someone who's renting a system, perhaps under the graduated program, and you are brand new to operate any of this stuff. We'll be on site with you the entire day. Make sure it's running correctly on your vehicle. Setup is good, initial capture is good, and begin through the post-processing steps. So that is mandatory if you are a first-time MX renter. If you are an experienced user of some of the systems, whichever one you're going to rent, you don't have to do that. You can just launch right into the fee schedule for renting. And I should also point out, this is definitely no way saying that if you are exploring a purchase, we're going to make you pay for a pilot day. Not at all. You kind of see the top line there. Really, the purpose of this is someone wants to actually try this out on a real project basis and just kind of dip your toes in the water. We will happily process that 1 day's worth of data and give you not your finalized, extracted features, but we'll get you at least a point, classified point cloud, colorized, registered to control. Now you can take that across the finish line from there. And so just again, make sure we're not competing with any of our customers. We do charge a nominal fee for that. But like I said, it does double duty as training as well for folks who are new to the system. And so that's it on the rental program. Before I kick it over to Skyler real quick, Marissa, any chat questions about the rental program, or we keep it moving here?
No, we don't have anything at the moment, Chris.
Perfect. Thanks, Marissa. And then one last quick announcement. We'll bring this up at the very, very end of the session for everybody. We are offering a totally free field day event. You can scan the QR code there on the screen or visit our events page on the website. And this is not just about mobile mapping, though the MX9 will certainly be there and we'll be able to dive into that more and get your hands on it. But the new X12 terrestrial scanner will be there. LiDAR drones, I believe it's the Quantum, maybe micro drones as well. So a lot of fun gear will be available on October 4th all day. And it is a drop-in event. So if you can't make it for the whole day, or there's one or the other of the various equipment we'll be demonstrating that you really want to see, plan for that. This is near Carthage, North Carolina, all of the details on the website. So I just want to give that quick plug for folks who are really trying to investigate this and other emerging technology platforms. And with that, I will stop my share and kick it over to you, Skyler.
Thanks, Chris. Great summary. Let me pull up my screen and we'll get into a quick comparison between the systems. I always feel that it's best to just show the actual data. We can talk about spec sheet versus spec sheet, but seeing what the actual data looks like has always kind of helped people come to an understanding of what each system will give them. So what I have here to start off with is the same area that I collect. I basically collect the same stretch of road with every system that comes through, even if it's a beta system or something I'm just working on here in Colorado. I always go out and collect the same exact section, so it's an apples to apples comparison. So I just want to kind of take a look at a few areas in the data set to kind of show the differences between the MX50 and this is the MX9, but I do want to note that it is a V1 MX9, so it's from before the recent update. Then after I show this comparison, I'm also going to show a comparison of the V2 MX9. I just haven't been able to capture this benchmark area with a new V2 MX9 yet. So we'll go look at a certain area here. So you can see this intersection here. The first thing I kind of want to focus on a little bit is the density difference. So in this case, we're about double the density on the right side as we are on the left side of the MX50, and the V2 actually has some increased density capability over what we'll see here. One thing I note is that typically, a lot of the manufacturers, we've kind of had a race for more density when testing and running the new version of the MX9. There's only a few scenarios where I think you'd want to actually run at the higher density that is available on the V2. The original 2 million points per second is still an option in the updated MX9. And for most jobs, that's plenty of points. So there are a couple particular use cases like PCI road condition on a highway that you're going 65 or 70 miles an hour on, where that additional density might be helpful. But for a lot of use cases, I try to push customers to only capture the data that they actually need for their use case, because the data is quite large, and capturing an extra couple million points per second that you might not need can add up quickly. So for most use cases, I still prefer to run it at the density that we're seeing here. But like I said, right after this, we'll take a look at the full density rate on the updated MX9. Let me zoom in on a road marking. I like to kind of show the road markings so that you can see how many points are on there. And then you can see here on the right with the MX9, the kind of pretty obvious increase in density that we can see there. Let me actually make sure both these scans are on. There we go. I had one of the passes off, so a little bit better density now that I turned that second pass on, but still you can kind of see the difference. One of the things I kind of talk to customers a lot about is like I was saying, what do you need? So for this case, I could still extract all this road striping. I could extract, the arrows, most signs, curb and gutter, things like that. This is all sufficient density for that. It did have a pass in each direction. A pass in one direction, we'll turn that one on. So like what I just had is still pretty sufficient for everything on your side of the road, everything in the other lanes. When you start to get, to this turn arrow right here, that's where you kind of have that border of things start to fall off, might not be extractable, where we'll do that same thing here. So you can see the turn arrows that we're looking at there, a little extra density. Let's turn off the first run. So you can see we retain a few extra points, a little more definition on those turn arrows. There was a car here, so that kind of took away some of that. But that kind of shows a little bit of the difference in range. These are both at their higher rate. So one area where the range really comes into play is by slowing the PRR, or the pulse repetition rate, down on either laser, you achieve longer range. The MX9 has a lot more room to do that. So I can slow this one all the way down to a lower density than the MX50 here on the left, and then the range will be almost double what the MX50 is. So the range difference isn't as big as a lot of people think when they're both at their max PRR rates. The difference is that for particular use cases where you need more range and you want to trade off some density for range, you have more room to do that with the MX9. Where the MX50, I can slow it down to 166 kilohertz per laser. I can get out an extra 20 meters or so. With the MX9, I can slow it down from 3.6 million points per second to say 200,000 points per second, and I can go all the way out to 350 or 400 meters. So you have a little bit more flexibility with your settings on the MX9. Let's take a look at a couple things in 3D just so we can see some of the more upright features. So let me go home, 3D view. So I wanted to show something like that light pole, and then I'll show the same light pole over on this side. So hopefully this shows up all right for you guys on the meeting. I know sometimes the points are a little hard to see in the meetings, so I'll maybe bump the point size up one on each of these. You can see for something like extracting this light pole, there's sufficient points on either side. Another area where the point density does kind of come into play and the difference between the systems comes into play is the power lines and the utility focused customers. The MX9 does do a better job at capturing power lines that are at a pretty far distance from the collection site, so generally transmission towers and things like that where you're not quite as close to the power lines. Local distribution lines that are close to the road, either system usually gets sufficient returns on. But that is another area where you're kind of right at that borderline between the two systems. Transmission towers, you're a little farther away, you need that extra range. You need those multiple returns. There are some scenarios that I can even pull up later if we have time, where you'll see the MX9 does get sufficient returns to extract power lines, where it's right at the edge of the MX50's range, and it'll still get returns, but you'll just have sparse returns and have to do manual intervention on the extraction process, where the 9 might be able to automatically extract the power lines. So now that I've shown the MX50 versus the MX9 in the same area, let's take a look at MX9 versus updated MX9. So this is the previous generation MX9. We've had that around for a few years. It had 5 megapixel cameras, and it had the VUX 1HA 18s, so 2 million points per second total. The update included higher resolution side cameras and pavement camera, and then it updated to the VUX 1HA 22, which is the 3.6 million points per second total that Chris was mentioning before. So I'm going to go to this data set. So this data set is collected with the updated MX9. So we do have some increased point density here on the road. You can kind of see, let's change the color a little bit, hopefully make that more visible for everybody. There we go. And so there's a couple changes in the lasers. Of course, is the density, which we kind of already talked about, going from 2 million points per second total to 3.6. But another interesting change is there's about 10% further range per PRR setting. So the previous MX9 and the current MX9 both have variable range based on the density that you're collecting. But if you take 2 million points per second versus 2 million points per second, the new one you'll see about 10% further range. So you won't see further range at the max rate versus the previous max rate, but if you hold the density consistent between the two systems, there's about a 10% difference in range. Most cases, I think it's a little bit overkill for just like asset extraction, for road surface modeling, things like that. You probably don't need to run it at this full density that we have here. But one of the cases that I mentioned previously that I do like it for is things like pothole and rutting and basically any kind of pavement condition inspection on a highway. That's generally one of the workflows that we require the most density to do well. And so being able to have that extra density, you might get away with one less pass, you might get away with going the speed limit instead of slowing down a little bit. There is a couple scenarios where that extra density could be key. And then I also wanted to highlight the new cameras on the system. So unfortunately, the run I pulled up isn't the most busy run, so there's not a ton of things to see. I'll jump a little further in so we can actually see some guardrails and things like that. So these are the updated 12 megapixel cameras, and if needed, I can pull up the previous 5 megapixel, but also bring up the Ladybug 360 camera to kind of show the resolution difference between those. One key point that I really like, because I'm generally kind of pavement focused, I do a lot of work on pavement inspection and stuff like that. For our updated pavement camera, it's a much wider angle lens than the previous one. So where depending on lane width and the height of the vehicle, there were certain scenarios with the previous camera where you were just barely getting the full lane. Mounting the system up higher could always help that, but we didn't really want you to have to tailor your vehicle installation to being able to capture the roadway. So this wider angle lens here captures pretty much 1.5 lanes on either side. So it'll kind of capture your full lane and a little bit of buffer zone on either side. And so even if you mount it on a lower vehicle, you're still relatively safe on having your whole lane captured. And these images are pretty prime for things like crack detection that Chris mentioned earlier. They can be done with other cameras, the Ladybug, things like that, but I know most of the crack detection algorithms and softwares that do crack detection, this is kind of their ideal scenario, is just a downward facing image of just that lane with plenty of clarity, and you can set up the trigger distance where the bottom of this image will overlap a little bit with the top of the previous image, so you don't have any gaps, you don't have any missing sections in your lane analysis. A new update in TMI that is kind of relevant for that workflow is you can now set your trigger distances independently for different cameras. So that is something that kind of came about from that workflow, is you could set your Ladybug camera at a 7-meter trigger distance just for colorization purposes and for kind of navigating around the point cloud, but then you could set your pavement camera at a closer spacing to make sure you have plenty of overlap between images. So previously everything had to have the same trigger distance or trigger time. Now the cameras can be set independently. Close this out, and then I'm going to open up the panoramic view. I just want to show a little bit of a difference between the Ladybug and the side planar cameras. Okay. So there's a little bit of a difference in the resolution. A guardrail, it probably doesn't really matter for most use cases how clear and crisp the images are, but the main use case where that extra resolution can help is things like reading house numbers on houses that are a little ways off the road. The main use case that was recommending the higher resolution side cameras was for reading pole tags on utility poles. So most of it's kind of focused on being able to read something that you weren't able to read in the 360 camera. Okay, so unless there's any questions on the comparison between systems, I'll switch over to the workflow that we were kind of talking about. And I took a note that as built and asset management were kind of tied, so I'll just kind of go through some of the extraction tools that would be common between those two workflows. If there's any questions, feel free to come off mute and let me know. But other than that, I'll switch over to the workflows. So this is an MX50 dataset that I use for testing a lot of the extraction workflows in TBC. So a lot of the tools that have come out in the past were tested on this dataset, or ones that are coming out in the future also get tested on here. It's not the only dataset I test on, but it's got lots of things in it, so I like to give the extraction tools a workout. There's lots of polls, lots of signs, things like that in here. So let's take a look at some of the features that are extracted, and then I'll kind of talk on how those tools work, and we can even run through a couple extractions if we have time. So in this case, I've kind of extracted, let's turn everything off. So I've done a lot of the curb and gutter, some lane markings, the light poles, power poles, signs, some of the crosswalks, some of the road signs or paint signs on the road. This is what most of the performance testing is done. There's certain sections of this data set that get timed, and the extraction speed of certain sections are kind of how we base our performance improvements. So let's turn these back on. So we'll kind of go through the different tools that we currently have. Some of the other ones I can't mention yet, but there's additional extraction tools coming in the future. Let's go to the point clouds module, and as some of you might know, the point clouds module is just agnostic to where the point cloud came from, so all these tools would also be relevant for any of you that are using static scanners. If you're just bringing in an LAS from a non-Trimble sensor, you can still run these same tools. So the workflow, if I'm kind of trying to turn a point cloud into extracted assets, or a course as built of where everything is, my workflow is generally to classify the point cloud regions, which you can see I've already done on this project. So you can see I've got my buildings, my trees, my poles, all that. You can see the default region was full of vehicles and traffic and stuff like that. So I'll turn that off, and we got everything cleaned up. And this data set also does get used for some testing for the classification. You can see an issue we had here where there's a little bit of ground that was getting classified as power line on this rail line right here. But overall, since this is a test project for classification, it does classify pretty well. All the trees kind of have individual trunks, which is something that you'll notice is key for them to have a good classification. When they're all bunched together, that's when you usually start to get errors with the vegetation classification. After classification, I'll kind of group up my assets by a type. So signs and poles, I'll usually kind of extract everything in the signs and poles groups. Then I'll usually extract any trees if I need to do trees, so I get all my point features out of the way. And then I'll usually move into more linear features, which would be the power lines, the curb and gutter, the lane line markings, things like that. So you just open the extract point feature command here, and we kind of categorize it based on point and lines. So you've got multiple different point feature types, and they're all going to be in the same tool. And then you've got multiple line feature types, and they're all going to be in the same tool. So as of right now, we have the tree, pole, and sign extractors. So let's just go to the sign extractor. You have a manual and automatic mode. So if you go to the automatic mode, you're just going to search the entire point cloud. It's going to take a while. You're going to extract everything, and then you come to a QC step where you navigate from sign to sign and mark if it was correct or not. I'm not going to run that right now just because it'll take, I think on this data set, it takes 3 to 5 minutes to do the entire sign extraction. But I wanted to mention the differences between manual, because manual is more of a semi-auto one. You still click somewhere on the sign, but you can extract all the features out of that sign automatically. So if I just click anywhere on this sign post and then extract the attributes, it's just going to go in and it's basically doing height, diameter, lean angle, things like that. So you can see them here. I don't have a feature code in, but these can be mapped to attributes in your feature code. So typically my workflow is to do an automatic extraction. In this use case, I think I get low 90% of them with the automatic. So I think it was 92% of the signs in this case were found by the automatic. Then I'll go through and do a semi-auto one to grab anything left. So I'll just click on a couple of the missed ones, extract their attributes automatically. And then every now and then you'll have a sign that's way off in the distance, or maybe like this pole, it's kind of very sparse, where you might have to do some manual attribution. And if you're doing that, you can just, for something like height, you just click the height field, click at the bottom, at the top, and it'll automatically measure that height for you. For trees and poles, the workflow is really the same. You just have a few different attributes. So for something like tree, you might have your trunk diameter, your tree spread, and your height, where power pole doesn't have a spread, but it has lean angles, things like that. So the lean angles is the newest one we've added for, I think it's a little bit more of an asset inventory kind of workflow for some municipalities and things like that. They want to flag any signs that are leaning over above, say 10 degrees or something like that, so that they can send a maintenance crew out there. So that's one of our newest automatic attributes that we extract. So after the point features, we can look at the extract linear features. So our options here are overhead lines, curb and gutter, and lane lines. One thing I like to talk about usually when I get people in a webinar for these is just because it's called the curb and gutter tool doesn't mean that's the only thing you can use it for. We actually have lots of users using it for all kinds of other things. Some of the things we found early on in testing that it works well for is it's basically a break line extraction, so anything that follows a similar template shape in a linear fashion can be extracted with it. So some of the things I use it for are guardrails is a big one, and jersey barriers, because they kind of follow that attribute. So we named it after the type of feature that it was designed for, but it's we keep things relatively generic, so it'll work in other cases. So you can add more nodes, and basically you select a cross section. We can actually do that on one real quick. So we have a cross section here. I cut it right at a storm drain, so it looks a little funky. But you basically place your nodes. The nodes are going to be what template it's trying to follow. You can select draw or not draw. So let's say you have back of curve, top of curve, bottom, and then like flow line, but you don't really want to draw your flow lines. You can still use it to follow the template, but you would just uncheck that node to not have it actually create a line there. And then you run your extraction, you set your interval, so that's going to be the spacing interval that it's searching for points, your minimum confidence. What I prefer to do is I set my minimum confidence really high so that if it's even a little bit off, it just stops. And then you can manually, you can adjust your template, you can reshape your template, or you can click auto fit and it'll try to auto fit your template to the current code. So something like a curve, the areas where that's going to happen is, you're going into an ADA ramp and it starts to taper down. I want it to just stop as soon as it's a little bit off. I'll adjust my template for the changed height of the curb for the ADA ramp, extract across the ramp, go back up to the next section of the curb, and then continue extraction with my normal template. Let's take a quick look at the other linear feature options. So let's look at an overhead line. So in this case, for the overhead lines, I like to turn off the vegetation so that I don't have stuff going on in the background. We'll do extract line feature. Overhead lines, we basically give it a start and an endpoint. So I'll click this pole and that pole. And you can do, it doesn't have to be pole to pole, so it can go between poles. So I think my record is I did like 10 miles in one go one time where we had nice consistent data and I gave it, a good start and end point, and it ran for 10 miles without having to be re-aimed. So then you select your line. You can do an adjacent search or just select the additional lines. The adjacent search is going to look around that box into the kind of salmon colored box to try to find more lines. In this case, I'll just turn that off and do a couple more selections. So then your other options in this tool are going to be search length and search width. So you can see how long we want to search. Basically, the longer search length is going to help it jump any kind of little gaps like that in the returns. The search width is basically going to give it more freedom to follow curves and bends. But then the trade-off is if you give it too much width to search, it can jump to an adjacent line. So generally, you'll kind of, maybe the first couple extractions on the project, I'll mess with things and I'll kind of figure out what the best settings are for that particular setup. So I'll, test it on a couple little sections, get something I like, and then run it the rest of the way. So let's run the extraction real quick. And there you go. You have your extracted power lines. You can name them. You can change your line settings and add them to a layer and change a color. There is a post QA/QC where you can smooth them, things like that. I generally leave these ones alone. They're usually in the right catenary shape, but for curb and gutter, I like to run a smoothing operation on a lot of the curb and gutter stuff, just because that generally naturally fits the way that they pave curbs a little better than the chorded straight lines from the template. So in overhead lines, I generally leave it to the original. Curb and gutter, I like to run the smooth curve option before saving the settings. But yeah, that's kind of the workflow for extracting some of the point features, some of the linear features. If there's any questions or things somebody wants me to focus on, be happy to go into it, but thought I'd leave the last 10 minutes or so in case there's any discussions or if Chris wants to go over anything else.
Yeah, thanks for that, Skyler. No other questions in the chat at this time, so I would say if you want to keep going a little bit longer on some other, just kind of TBC functionality, I think that might be good for folks until someone pipes in and says they've got a different question.
Okay, sounds good. So one of the other workflows that I can show, since I just extracted some of these lines, is the measure line clearance option. That's one of our more recent options. It was a request that came in from some of our customers that are doing mostly utility work. They had certain clearance requirements that they were required to check on long stretches of road. So manually clicking each line and checking the clearance using the measure vertical clearance tool was becoming a little tedious for them. They wanted something to help speed it up. So it's not going to be fully automatic in every way, but the measure line clearance tool is what we came up with to kind of help them with their workflows. Okay, so the way this one works is you select your lines. So I'm just going to control click each of these lines. So you can see I have 5 lines selected here. My point cloud region selection is going to be to what region am I searching. So I can't always just say all regions and it's just going to measure the clearance to whatever's there. But for some of the bid specs that I've seen, they wanted it just to ground. So they didn't really care if there was a little vegetation there, if there's a bush or something. So we'll select just ground. You select the search radius. We'll see how this one runs if you have low density data. So like let's say I'm measuring out here where the density is kind of falling off. You might have to turn up your search radius some to be able to find a point to stop the measurement tool. We also put this flag clearances less than field in here because most of the bid specs and things that the customers were showing me and the reasons they had it is they didn't care what the measurement was as long as it passed a certain threshold. So we kind of put that in to just, we flag them as red to say, here's the only ones you need to actually look at. You can send a crew out to take a look at it. You can measure it again yourself, verify that it didn't accidentally measure to a bush or something. But it was basically a quick way to just skip a bunch of them that were well within spec. You can just have your flag clearance set to, even if it's a little bit less than the required amount that you have to fix, you can set that so that you only spend time looking at the ones that get flagged instead of all the ones that have plenty of clearance space. So let's run the measurement. So you can see we get basically a line and a measurement for each of the lines. And some people kind of wonder how we find those. So it's going to be the lowest point in the curve. So that's based on the inflection point of the line. So when it goes from a negative slope to a positive slope along the line, we measure at that location. There are some other ways that we can run this rule set in the background if there's a requirement from a customer. So we do have an option that you have to tweak some things behind the scene that I can always help somebody out with, but we do have an option that measures at a set interval along the line. So it'll take a measurement every foot across every line. And so that will take much longer, of course, but for certain use cases, that's what they want. Let's say they're mapping a corridor for a large trucking shipment where clearances across the entire stretch could be an issue. We do have an option so that you can just take all these measurements and report every 1 foot spacing what the clearance to the ground is. We have a couple options that will find the lowest clearance anywhere on the line, even if it's not necessarily the lowest point on the line, which that gets a little confusing sometimes, but you could have a high point on the line, but then the ground can come up over at that section and have an actual lower clearance, even if it's not the lowest point. Right now, it's set to do the lowest point. But if anybody has any questions or feedback on this tool, it's one that I kind of pushed through and did most of the testing on, so I'm always looking for feedback on if people like it, if people want to change it, things like that. You can also use it for things like bridge clearance. I mean, it was designed for overhead lines, but you can always draw a line string across an overpass or a bridge and use the clearance tool there, or just manually measure it with the measure vertical clearance tool, which can just be clicked on the point cloud. What other features would be kind of interesting to take a look at? So one of the things that I did a lot of the testing on this particular data set with for the asset management kind of users is the integration with ArcGIS Pro. So we can talk to that briefly. there are a couple different options if you're trying to get your assets into ArcGIS Pro. So one of the options is to register your dataset, export it to TMX Publisher, which then has a plugin for ArcGIS Pro. And in that case, you would actually see, you'd have like your trajectory. Let me turn on my trajectory lines. Layers. So you would actually have your trajectory of the vehicle that would show up in your ArcGIS project. You could navigate using ArcGIS, and then you could click open a certain spot, and it's going to open a second window that would have your 360 panoramic view in there, and you can make manual measurements in the point cloud there, hit sync, and then that syncs back over to ArcGIS. So that's the most integrated option for ArcGIS. But the downside is you only have manual measurement tools available to you. The other option is to do your extraction in TBC and use the GIS Connection Manager to connect to a GIS Esri geodatabase that is then live between your ArcGIS Pro project and Trimble Business Center. So in this case, I can turn on all my layers, and basically I have all these GIS layers that were set up in an ArcGIS project. Once I go to GIS Connection Manager and set that database, so you can see here's shapefile, file geodatabase, or an enterprise geodatabase. Once I set these up, this can then be a live connection of all these assets. So I can just say write features to GIS. It's going to write all of these features to that database. I can read features from the database. So if they're doing, let's say they have a sign inventory and they have the previous sign inventory from years ago, I can read those in so that I'm not extracting the things that we already have. I can then each day or each 10 minutes just write a quick update over to their database. I can pull the schema for different assets from the database. So this GIS tab is one of the modules that we actually include with something like the mobile mapping subscription. We generally include it in most mobile mapping sales because it does have quite a lot of use in syncing to those databases that a lot of the asset management type companies that we deal with, that's their kind of end goal, is to sync things into a current database that they have. Instead of just exporting a new shapefile at the end of every day, you kind of keep it as a live connection, less imports, less exports. It's more fluid and current each day. Yeah, I think that's pretty much it, Chris. If there's any questions or something that somebody wants me to dive into, I have a few extra minutes, but that's kind of that covers most of the asset management kind of workflow that people were mentioning.
No, I really appreciate that, Skyler. And yet, everybody, thanks so much for spending this hour with us this morning. Yeah, any questions, feel free to take yourselves off mute or drop it in the chat. We'll be on here a couple more moments, but if not, again, thanks for the time and have a great rest of the day. And also plug again our free field day event. This is in Carthage, North Carolina, coming up on October 4th. Check out our website or scan the QR code for more info. Hope to see anybody in the Carolinas or Virginia particularly. Should be relatively accessible, so hope to see y'all there, many of y'all there. You know, if folks do have questions, I can probably unmute everybody all at once if you're having trouble with that. Like I said, feel free to unmute, speak up, or drop any questions in the chat. Be happy to take them here for another few moments. Let's see here. Looks like I can't actually unmute you all. So yeah, again, any questions, reach out individually. You've got our contact info. But if anything at this moment, please speak up. Otherwise, yeah, again, thanks so much and have a great rest of the day.